Good morning, everybody, and welcome to IGTV. We have on the program with us today, of course, Mark Capers, and you can see Mark in the background. All right, and Mark is going to give us the InfraGard Insights today, and this is going to be security for storage and backup. Good morning, and welcome to the program, Mark. Why don't you take it away?
Morning, Joe. This morning, I'll give you a quick primer on storage and backup systems. Talking through some quick definitions before I start. Typically see two different terms bandied about for those who might not be familiar: NAS, or network attached storage, and SAN, storage area network. A NAS, network attached storage, is typically where you have your storage units connected directly to a shared network, and the data is accessed through a file mechanism. There's kind of a front end that provides HTTP or NFS, or which is the SUN network file system, or through CIFS, which is Windows Active Directory protocols, and it's a file-based access model for the data storage. The other variant that you see a lot is storage area network, and that's where the backup units, the disk arrays, etc., are typically servicing a cluster of hosts, hopefully on a private network. I'll get more to that in a minute. And that's a block I/O service, so the input-output, it's a block service. It can use some of the same protocols, or the same families of protocols as NAS, but it's usually more direct. And actually, there's a larger extension of the SCSI interface that's used a lot with Fibre Channel. So typically you'll see either a Fibre Channel or Ethernet, gigabit Ethernet on a back end of a bunch of servers cluster, although they can be used for server-to-server communications for failover type situations. And again, there is the development of hybrid models now where you have the SAN elements attached to the same network as the NAS, and then the communications negotiated through the front end to allow users to directly connect to SAN, although I would want that really, really tightly nailed down before I would use it, and we'll talk about that shortly. And for this morning's talk, when I talk about backup systems, I'm really referring to offline media and systems used to capture media, replicate it, and then move it offline. So moving forward, why do we think that we need to treat network-attached storage or storage area networks differently? And I think a lot of the reason is most enterprise security is perimeter-centric. We focus a lot on external threats, and this technology is a good enabler for massive amounts of storage, but you're aggregating your storage and you're putting a lot of your information on one system, and you're moving that closer to the network. And if you're not careful about how you do that, you could open yourself to more vulnerabilities and more risks. So you really need to pay attention to not only your external perimeter, but what are your internal threats, and how do you segregate your data inside now? And as you move to this technology, how do you make sure that the wrong people in your organization don't have access to very sensitive information? As we see with things like WikiLeaks, part of the breakdown was certain people had classification access to all sorts of damaging data, and maybe they needed to do it on a need to know, maybe they didn't. But that's probably an organizational and a people problem more than a technology problem, but you have to have the tools to enable that process to work. So the concentration of different legacy systems, a single security breach now can compromise a much larger amount of data. Your regulatory and your compliance issues tend to get a little more complex because these systems can now be geographically dispersed. Your storage area network and your network attached storage can span multiple data centers and, in fact, global. And that's not a bad thing. It's great for disaster recovery and fault resistance. Certainly several of the services that I dealt with at EDS and HP, we looked at doing solutions in each data center through private networks and through SANs to allow us full fault recovery in case one of the data centers went dark. But with privacy regulations and other regulatory compliance issues, you need to make sure that the replication doesn't give you issues with, authoritative sources. If the data, you have integrity issues with the data, as well as, certain privacy laws affect data in one place, they may not affect it in the other. Again, I spoke about, when you're, this stuff is directly attached to your network, so you've got to take care, because your number of attack vectors and the number of vulnerabilities is going to increase, and if you don't bring the compensating controls that you had with all the old servers and the individual disks going forward, you could be putting yourself at risk. So the key to SAN and NAS is going to be defense in depth. Make sure you have a layered defense, overlapping layers and controls, and that's critical to protecting the quality assurance and the information. Quickly talking about the different flavors of vulnerabilities that you'll typically see with this stuff. Again, you've got devices on the network, so you've got vulnerabilities to the actual devices, and with both these types of storage solutions, you potentially, your database vulnerabilities, operating system vulnerabilities. HTTP is a very good one that you need to pay attention to. And most of all, poor authentication and access mechanisms. So you really need to pay attention about how users are getting into this stuff and how that ACL regime works and how their rights work, and making sure they can only see what they need to see and not other things. If you are providing solutions to your clients and you have multi-tenant issues, you have to be very, very careful that, if you're doing multiple payrolls for different companies, users from one company can't see the payroll in another. And in some cases, you want to make sure that users who can't see the payroll can't see the payroll. The data access issues for the protocols involved, again, for network attached storage, both CIFS, which is the Windows message block based information file system, and NFS, the Sun network file system, take good care to secure. I mean, NFS was never really intended to be a secure protocol by itself, so you need to have other authentication and encryption mechanisms for using it, especially during certain types of network attached functions. Some of the passwords can be in clear text, so you're going to want to pay attention to using things like VPN and encryption on the fly, on the wire, as well as at rest. In the situations, storage area networks, some of the same issues exist with some of the protocols used, mostly in SAN configuration, though that's a very private backbone. It should be physically separated, or a VLAN at minimum, I think, in my humble opinion. So I would avoid architectures where that stuff is on a shared network where devices other than things intended to talk to it can talk to it or access it at all. So some of the connectivity vulnerabilities and network vulnerabilities, again, you get database protocols, IP spoofing. You might open yourself up for denial of service attacks and session hijacking. And the other thing to look at is the management channel security, because how you manage these things, and you need to protect that as much as you need to protect directly getting the information. So when you look at securing these storage resources, the process you need to think about going through, and at the risk of sounding like, beating a ragged drum, you need to identify and assess all your data assets. What are your confidentiality requirements, your integrity requirements, and your availability requirements? And again, look at your regulatory compliance with that. So, what are the levels of security you need for those things, and what are the regulatory posture that you need to accomplish that through implementable policy and standards. Next, you need to go back and look at the infrastructure, and you need to identify and assess all the storage interfaces that you're going to be using with these technologies on the storage system. Make sure that you understand the protocols used to gain access to these things by both the user and the management, and protect those appropriately. And as well, you need to identify and access your encryption requirements, and with that, something that's very important is your cryptographic key requirements. It's great to lock up the data and encrypt it, but you have to have a robust mechanism by which to store, protect the encryption keys and recover them in the event of disaster or failure. So after you've kind of done those steps, what you typically would do is use a risk domain model to, kind of pool data elements of like levels of security, if you will, and then apply the controls to protect that appropriately, and then go back and also implement your storage system security on the hardware and protocols. And again, as you go through that, you're going to align your storage mechanisms. What are the authentication and access controls used? What are your encryption methods? And you're going to align that with your policy. And while you're doing that, make sure that you've paid attention to your appropriate service continuity. Availability and integrity are things that often get overlooked when we talk about CIA, because we all concentrate about the data leakage and information getting spread out. The other parts of security are equally important, making sure that data has your required integrity, especially if you're in a transaction model, and it's available. If you're in a real-time business and you can't get to your data, you can't do business. Monitor your physical access and control, and make sure you implement good network segregation, both physically and logically. And then go out and make sure you've got good management and monitoring on your management channel. So talking about the management and channel and monitoring for a minute. Again, this is the kind of the keys of the kingdom, because this is how you operate the system. So you need to make sure you protect it. Make sure you secure the management interfaces. So, avoid unauthorized access due to insecure protocols like Telnet and HTTP. So you need to, use some SSH and SSL. Harden the management application where you can. Tightly control, your access privilege. Again, these are privileged accounts. They're administrator, they're root. You have to treat these things with care, and make sure that you're not using weak passwords. Change the default configuration and default passwords, and make sure you follow best management practices for your administration and your management of user objects. And again, that goes back into remote support. If you're remotely controlling these things off, from a user segment, and they're sitting in a data center on a server segment, make sure that you're using VPN and two-factor authentication if you can. And really make sure you've tightened down those remote access into the back end of these things. And make sure you're using your good configuration management with these, and enable and utilize audit and event logging. Again, if you don't understand what's happening in these systems, or what these systems tell you that's happening on them, you're not going to be able to diagnose them. Lastly, a word on offline backups. As we move these, as you replicate your data and put it in offsite storage, make sure you secure the backup system. Make sure that the backup system admin user is following the same good practices, especially if you have a backup user that is enabled on a lot of different systems to pull data to back it up. Enable and review your log files for backup events and segregate that system appropriately. Understand your data format and your life cycle. If you have stored media, make sure that you can still read it. These things go obsolete. We're no longer using DATs, we're using DLTs. No, we're moving to worm drives. Make sure that you migrate that data and then destroy it appropriately, along with encrypt it. You want to encrypt it, and when you encrypt it, make sure how, with what, and make sure you still have the keys to recover it. And lastly, test your restore process. If you have a lights out recovery process, make sure you test that with some frequency. And that's pretty much storage and backup in a nutshell.
Yeah, well, once again, you're jumping through hoops there for us, Mark. Just hang on. Let me manage my volume here. All right, good. We've got a question from one of our internet chat people. All right, and the question is, for our personal home use computers that we use for business, and I've got more coming here. Hang on a second. Hang on. Okay, yeah, okay. For our personal home computers that we use for business, what protection would you suggest for email to ensure that emails are encrypted? That's an open one.
Yeah, I think it, to go back to requirements a little bit, I guess. Depends on your mail client. That's going to be the big driver. Microsoft Outlook now has some built-in encryption and certificate support. So if the organization supports that, use that. Otherwise, PGP has a plugin that works with Outlook and most mail clients, and that works pretty well. And again,